Hello, Internet. Okay, you don't need to watch the whole video because I want to tell you right now what this is all about. Liquid AI released new models today, and they're not based on the transformer architecture that ChatGPT is based on. That's all you need to know. Now I'm gonna fumble around and look at the website. I'm Albie13. This is Liquid AI, Liquid.ai. They're liquid foundation models that they call LFMs. So the trend is to call it something with three letters, and they call this one LFM, which sounds like a large language model LLM. So let's see their first generation published today, announcing the first series of liquid models, a new generation of generative AI models that achieve state of the art performance. And they go ahead and show you this right here. And the immediate thing that stands out to me is here's Llama 3.1, 70 billion parameter. What they put prominently is their LFM 40 billion parameter mixture of experts, MOE. Um, then you have the smaller models over here. And so they state that the number of active parameters goes from 0 to 100 on the bottom. And then what we have is the benchmark from MMLU Pro, which is supposed to be something serious. This is true that the scoring high, now you will notice that this goes from 0 to 60 something, 65. So 100 is way up there. But anyway, because you're dealing with smaller models. But so straight away, what do we also see in the key, if that's the correct term? Transformer models are circles. And then you have hybrid indicated and RNN indicated. Square, where might a square be? Square is way down here. So what are they trying to say with that? Maybe they're trying to say that square type RNN is not the way. They don't seem to be doing very well in terms of scoring higher. They try to say that liquid models are performing better than all of these transformer. And as you keep growing larger and larger, they're still performing better and better than all of these transformers. And then this is some kind of trend line that they've indicated, a trend zone. So it looks impressive on paper. I tried them today. I tried their LLM today, and I couldn't say I was super impressed. But that is just anecdotal, simple testing. And the thing that I didn't like about it is when I talked to it, it didn't seem very intelligent. It just seemed to tell me the same things, and then like I asked it something or said something specific, and when it would go back to kind of telling me the same thing. And this is something that you see on smaller models, and it's something that I didn't see when I was dealing with perhaps um, what are we looking at here? Let me just see if there's anything relevant to reference here. Not really, not really. So let me just continue with the takeaways that they say. They announced it, okay? 1 billion, 3 billion, 40 billion parameter achieve state of the art performance. Then they say try them today on the Liquid Playground. So they have it on this website, liquid.ai. You can actually use it without any account. You click on try, takes you right into it. Then it says that it is being optimized for this kind of hardware. Apple, NVIDIA, AMD, Qualcomm, and Cerebras high speed inference. They build private edge and on premise AI solutions. So, edge is indicating on device, okay? So, they're saying on device and cloud based for enterprises of any size. They are scaling LFMs and expect to introduce new and better capabilities across various industries. Better, new and better capabilities. What does that mean? Um, let's see what else they say here, if anything else of note. I expect to hear more about the technicality, the technical aspect of it. That's what I mean to say. They designed them on principles, whatever. Um, LFMs are large neural networks built with computational units deeply rooted in theory of dynamical systems, signal processing, and numerical linear algebra. So a lot of math and science they're throwing our way. A unique blend. Decades of theoretical advances. If you say so. Um, they are general purpose AI models that can be used to, I guess, with any kind of sequential data. And they specifically mention video, audio, text, and other things such as signals. And then let's see here. The name Liquid pays homage to the roots in dynamic and adaptive learning systems. Okay, very cool story you're telling us. Um, let's see what they're saying. That their smaller model, like the 3 billion, is optimized for uh, being on a mobile phone, for example, or a tablet. The 40.3 billion MOE mixture of experts is their big deal for now for tackling the complex tasks. Um, their goal is to develop useful models that are competitive with current best in class large language models. State of the art performance. We look and glance here and see that context length. They are saying they are at 32,000 context length. And that is better than some other competition, notably Microsoft's Phi 1.5 here. Gemma 2 has 256, and we're at 32. And then we also have Llama 3.2 meta, new release, 1.2 billion, 128K, 128,000 context links. So they're not there, right? But then you see the context length is small, but then you see the benchmarks is significant. 58 versus 45 for Llama, and 58 versus 34 for Google, and then etc. Bigger, 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 basically, right? And then they talk about performance for its size, which is what this is all about. This is an efficiency model. It is meant to perform better for its size class. This is kind of what we've been talking about when we talk about a small language model. Um, they are continuing to increase the performance of small language models, something in the area of 1 to 3 billion parameters. And they're becoming more and more useful, and they just are. I mean, what they're doing is they are crafting them to be on device, which is something that uh, uh, they never promised that they were going to be on device because they didn't know what they can get out of it. They always kind of leave it vague because they need the hardware to support the AI actually processing on your device. So they're like thinking about what hardware to use, and then they are creating more efficient and useful small AI um, LLM types. And so I'm just kind of glossing over these tests. They're saying that it's memory efficient. Inference memory footprint is significantly lower than all this other stuff. And the output length is indicating 10,000, 100,000, and then 1 million here at the far right, which is what they're indicating. I didn't get that wrong, right? 32K, I don't know why. Well, how they're referencing the 1 million output length tokens or whatever. Let me just read this part. They're talking about the transformer-based grow linearly with sequence length. By efficiently compressing inputs, liquid foundation models can process longer sequences on the same hardware. For example, a minimal memory footprint. Okay. Truly exploit their context length. Okay, this is something. They optimize models to deliver a best in class 32,000 token context length. And why is that other chart? Anyway, I'm just reading here, this chart right here, context length. They're at 32,000, and then, oh, claimed length, effective length. Okay, wait a minute. All right, okay, this is kind of what I've been talking about recently. Yeah, I just talked about this on X and in the AI community. This is like, what? I mean, this is really important here, and I'm gonna highlight this. They say that their context length is advertised as 32,000, but they don't have to advertise as 128,000 like Llama and Phi, and they are larger than uh, Gemma, which is Google. Okay, so then it's like, okay, then immediately they tell you what's the model's effective length, not how much information you can put in the prompt and the response that it gives you back, but what is the effective length of data that it can deal with. And supposedly they use the word exploit the context length. So this is something really, really important that goes beyond numbers, and they put it, funny enough, in numbers. So uh, if we go off of what they're telling us, Gemma, um, Gemma does 4,000 effective length versus Liquid's 3 billion parameter 32,000. So 4,000 versus 32,000. Llama does 4,000 again. LFM does 32,000. Then we have Phi and Llama, which all are effectively the same, which is like, this is just a first time release for Liquid. So this looks really, really good. And then, let's see here. This is saying that they're talking about what's effective based on this standard, and that the marks are very high for effectiveness, which is saying that it's at 94, and then this is 95, which is great, and 94, which is great, and 80 something is not so great when you have models that are performing in the 90s. So that's kind of the idea, and then there's other numbers to look at. The highly efficient context window enables long context tasks on edge devices for the first time. Again, edge devices are on the mobile phone. Okay. Meaningful interactions, improved document handling, RAG, retrieval augmented generation. That's what it's called when they handle documents. Their goal is to keep scaling LFMs across model size, train, test time, compute, and context length. Beyond our language LFMs, we have designed models for various data modalities, domains, and applications, which we plan to release in the next months. So we are going to see Liquid releasing things in the next month. So we are getting the diamonds in the rough here. Information that is worth listening to and looking at. Definitely a couple of points that were worth the read. And then we see here pipelines and infrastructures and all kinds of baloney. Building on a long line of research, we have developed new design space, whatever design space means. Let's see. Scientific buzzwords. Maximize knowledge capacity and reasoning. They're all about efficiency, reducing memory costs, inference time, all that good stuff. Okay, optimized. Okay, what matters here? Featurization. Wow, they really throw the words around on this thing. The funny thing is, this wasn't written by AI. Okay, what are we looking at? Featurization, computational footprint. As if anybody's going to understand this stuff, right? But Okay, Mamba's in there. Then you got Liquid. And then you got attention, linear attention, whatever. Audio, language. Okay. All right. They're built with, okay, LFMs are built with computational units that can be expressed as adaptive linear operators whose actions are determined by inputs. There's some technical stuff here. Join us as an early adopter of LFMs. As we are still in early stages, we welcome the opportunity to collaborate and discover strengths and weaknesses together. What are LFMs good at today? General and expert knowledge, math and reasoning, efficient and effective long context tasks. Primary language is English. This is good. They actually specify information that we would really want to know. Spanish, French, German, Chinese, Arabic, Japanese, and Korean. What LFMs are not good at today? Not yet. Zero shot code tasks. Right. This is not coding. Expected that. Precise numerical calculations. It still needs to stay in school for math. Time sensitive information. Okay. Counting R's in the word strawberry. Really, they threw comedy in here too. Okay, I mean it's a known issue with LLMs, and then it's saying that their unique non-transformer approach did not solve the issue for strawberry. So that's very interesting because that problem becomes everyone wants to know why can't we solve the problem of the AI reading counting how many R's are in there without having it actually listed and then read the list as like numbers or something like that. And then they were trying to say that, well, it's a tokenization issue, and there's a lot of additional research that has been going on, especially on the internet, which is valid because it's just testing and seeing results in that way. So then, human preference optimization techniques. They take an open science approach. If your enterprise is looking to experience the forefront, get in touch with us. Share your feedback. Join our red teaming efforts. Okay, that could be fun for someone who likes to red team. Let's see, Liquid product launch event. Come join us in October 23rd. What is that? Massachusetts? MIT? Learn more about Liquid. Okay. Are they gonna live stream this? RSVP right there. And email somebody. And that's it. That's the video. Do the comment, like thing, and I'll catch you on the next one.